A box manufacturer buys rolls of cardboard that are 150 centimeters by 6 meters. They want to cut templates that have dimensions of 17 centimeters by 28.5 centimeters. Show all the work to find the maximum number of templates that can be cut from the cardboard. So we looked at this the other day. We have one great big piece of cardboard. And we want to cut smaller templates from it. What are the dimensions of the big piece of cardboard? The big one. 150 by 6. And the smaller ones that we're cutting from it have what dimensions? Right, 17 by 28.5. What are our units? Are all of them given to you in centimeters? So we have 3 of them that are given to us in centimeters and the other one's given to us in meters. What should we do about that? Should we leave it in meters?
No.
What should we do? Change it to centimeters. How many centimeters are in 600 meters? I'm sorry, in 6 meters? 600. All right, so we have 600 centimeters by 150 centimeters. And we're cutting out templates that are 28.5 by 17. So for the first design, what do we want to do?
Divide 600 by 28.5.
Okay?
150 by 17.
Yes. 600 divided by 28.5 and 150 divided by 17. All right, so on your calculators, 600 divided by 28.5 gives you what? 21.05. Okay. Do we want the partials?
No.
So we just want the 21 whole parts. All right, 150 divided by 17 gives us
8.82.
2,550.
JJ, we couldn't hear you.
so 8.82. Do we want the 0.82? No. What are we going to do with the 21 and the 8? Multiply. So 21 times 8 gives us
168. My hand here.
168 templates that we can cut out. Whole templates. All right, so now we're going to turn the boxes. We still have a piece of cardboard that is 600 by 150. But we're going to lay the templates long ways this way. And see if we can get more cut out that way. So now we're gonna take 600 and divide it by what? 17. And we're gonna take 150 and divide that by, so what is 600 divided by 17?
35.29.
Okay, so what number do I want to use?
35.3. That's right.
Do we want the partials?
No.
No, we just want to use the wholes, so we want 35. And 150 divided by 28.5 gives us, okay, so what number do I want to use? Okay. What am I going to do with the 35 and the 5? Multiply them. So 35 times 5 gives me what?
175.
So what is the maximum number of templates that we can cut out? What's the maximum number? 175. All right, if we make that many boxes, so how many boxes are we going to be able to make? 175. If we make 175 boxes of dimension 17 centimeters by 28.5 centimeters, what percentage of the roll of cardboard is used and what percentage is wasted? So how do you think we can come up with how much is used and how much is wasted? Sarah, thoughts? Abby?
You have to divide whole box or the templates by the box.
Okay. How many boxes are we cutting out? 175. What are the dimensions of those boxes?
35 by 5.
Nope.
17 by
17 by 28.5. So we have 175 boxes. That are 17 by 28.5. And we're going to take the area that's being used for that and divide it by what?
The other one,
The other one? No. What's the area? What are the dimensions of the area that we're cutting it out from?
600 by 50.
There you go. 600 by 150. We're taking a great big piece of cardboard and we're going to see how much we're not using. What we are using is this much right here, and this is the entire area here. So 175 times 17 times 28.5 gives us what?
8,400. No, I did that.
84,787.
Oh, I didn't do that right. Sweet.
Okay. And 600 times 150?
9,000.
So what we did was we took the area of the templates, total area of the templates, and divided it by the area of the cardboard. So 84,787.5 divided by 90,000, is that going to give us what we've used or what's being wasted?
It's being wasted.
Used or wasted? Are we using this or is this what's left over? What's being used? All right, so take 84,787.5 and divide it by 90,000 and tell me what you get.
I got 942.08
I
centimeters
guess
squared.
points 94,208,333.
94%.
0.94, which gives you 94% used.
6% not used.
So that is 6% wasted. Very good.
Oh, okay.
And then do we check the other one?
No.
Because we're looking at the maximum number. That's a good question. We're looking at if we cut out the maximum that we can. If we used 168, do you think we would have more waste or less waste? We would have more waste.
Would it be over 100% then?
No. We would have a smaller percent used and a larger percent wasted. All right, questions on that? JJ.
What?
All right, using a nonagon, find the following. So a nonagon has how many sides?
9.
9, very good. 9 sides. Find the measure of the exterior angle. So when you walk around the nonagon, how many total degrees?
360.
360. How many exterior angles do we have on a nonagon? 9. So how do we find the exterior angle? That times 9 divided by 9. 360 divided by 9. So we take 360 and divide it by the number of sides. And what does that give us?
40.
40 what?
40 degrees.
40 degrees. All right, so I'm going to extend one of these sides like we did on our activity the other day. And this right here, when we extend the line to where we meet the shape, that's our exterior angle. The exterior angle and the interior angle form how many degrees?
Degrees or 180.
180. It's half of a circle. So I'm going to go down to C. How do I find the measure of the interior angle?
180 minus whatever the exterior was.
Right. And our exterior was 40 degrees. So to find the measure of the interior, 180 minus the exterior angle. So how many degrees is that?
140.
140 degrees. Very good. How many interior angles do we have on the shape? 9. And the measure of one interior angle was how much? 140. So how do we find the sum of the interior angles?
Multiply 140 by 9.
Yes. So what is the sum of the interior angles?
1,260.
All right, so we found that by taking the interior angle and multiplying it by the number of sides. All right, I can take the nonagon and break it up into what shapes? Triangles, very good. So I'm going to break this up. I'm just going to do one triangle. How many triangles are in here? 9. So at the top of this triangle, we have what we call a central angle. Why do you think it's called the central angle?
It's in the center.
It's in the center. How many central angles do we have? We have 9, because we can break it up into 9 triangles. So if I walk around the center, how many degrees have I walked? 360. If I want to find the measure of one central angle, what do you think I would do?
Split it up into triangles.
Okay, how many triangles are there?
9,
And how many total degrees were there?
360.
So how would I find the measure of 1?
260 divided by 9.
Yes.
How's the degree?
4 degrees.
Yes, it is.
What she said was the,
Yes, it is. Exact same formula. 360 divided by the number of sides. All right, at the bottom of this triangle, we have 2 other angles. These are what we call base angles. These are at the bottom of the triangle. They also have this other word, mitered. It's referred to as a mitered angle sometimes. All right, and the base angle falls in the middle of what?
interior.
The interior angle. So what relationship do you think we have between the interior angle and the base? Very nice. So to find the measure of the base angle, we take the interior angle and divide it by 2.
So it's 1.
What was our interior angle? 140. Divided by 2, which gives us 70 degrees. Questions?